Data anti-jamming method for ad hoc networks based on machine learning algorithm. Yanning Zhang and Lei Ma, Beijing Polytechnic, Beijing. Introduction. The use environment of the ad hoc network is relatively complex. In order to meet the needs of the use, the multi-channel routing of the ad hoc network has become a more popular network form. Among them, the multi-channel transmission technology of the ad hoc network is to transmit the cells belonging to the same virtual connection to the opposite node. Most of today's ad hoc network switching devices regard the different channels of the channel group connected to the same node as separate entities, ignoring the problem of interference between the channel group and the same pair of nodes. Even if the cell level traffic changes, it will to a certain extent the problem that some channel cells are overloaded and the remaining channels are basically idle can be avoided. In addition, because the data transmission of the ad hoc network will suffer a certain degree of interference, which limits the application of high-frequency signal scenarios, especially in the absence of anti-interference measures, the false alarm rate will be greatly increased. Based on the above research, this paper proposes a new data anti-interference method for ad hoc networks based on machine learning algorithm. The idea is as follows. Based on machine learning algorithm, the characteristics of the data transmitted in the ad hoc network are mined, and the mining results are classified. Second, build an ad hoc network information transmission management platform. Optimize the data anti-interference evaluation algorithm with a machine learning algorithm, and realize the identification and defense of malicious interference data. 2. Anti-interference method of ad hoc network data. The current data anti-jamming methods lack the feature classification process, which leads to poor anti-jamming effect. In order to solve this problem, this paper proposes a data anti-jamming method based on machine learning algorithm for ad hoc networks. First of all, based on machine learning algorithm, the data transmitted in the ad hoc network is processed by feature mining and classification, and the ad hoc network information transmission management platform is constructed. Then, optimize the steps of extracting the anti-jamming information features of the ad hoc network data and combine machine learning algorithm to optimize the anti-jamming evaluation algorithm of the communication data of the Internet of Things, so as to achieve the identification and protection of the ad hoc network interference data. The experimental results show that this method has high practicability and can meet the research requirements. 2.1. Classification of data interference types. Due to the wireless communication environment and its own characteristics, ad hoc networks have weak resistance to interference. The multi-channel transmission platform of ad hoc network mainly consists of 3 modules: microcontroller chip, RF chip, and sensor. The architecture of the multi-channel transmission platform of the ad hoc network is shown in Figure 1. It combines the versatility and expansibility in the data processing environment of the ad hoc network, and can normally control the high confidential data collection process, so that the technical control effect is better. Therefore, in order to realize the versatility and the scalability of machine learning technology, it is necessary to use machine learning as the basic framework to realize the control of massive high confidential data clients in the ad hoc network, and to complete the control between the client and the server by managing different distributed servers. Therefore, the intelligent control of the collection of high confidential data in the distributed network in the 2-layer model is realized, and the expandable space of the device application is provided. Therefore, the networked control architecture is designed as shown in Figure 2. Threats from the interfered nodes inside the network are much more dangerous than attacks from outside the network, and these attacks are difficult to detect because they could come from the interfered nodes and perform well before being interfered. It can be seen from this that special attention should be paid to the threat from the interfered nodes in the ad hoc network. And mobile nodes and infrastructure should not easily trust any node in the network, even if they all perform well, because it is likely that they have been infected. Since the mobile ad hoc network does not have a centralized management mechanism such as a server, this leads to some vulnerable problems. The lack of a centralized management mechanism makes attack detection a very difficult problem because it is not easy to monitor traffic in a highly dynamic and large-scale ad hoc network. This lack of centralized management mechanism will hinder the trust management of nodes and mobile ad hoc networks. Some algorithms in mobile ad hoc networks depend on the cooperative participation of all nodes and infrastructure. Because there is no centralized permission and the decisions in mobile ad hoc networks are sometimes decentralized, attackers can take advantage of this vulnerability and execute some attacks that undermine the collaboration algorithm. Network data protocols include TCP/IP, Microsoft, and Novell. The specific network protocol selection basis is shown in Table 2. In the process of data anti-interference, the lack of centralized management mechanism will lead to loopholes. This vulnerability may affect many aspects of operations in mobile ad hoc networks. Mobile ad hoc networks are built on open shared media, so interference sources can easily launch interference attacks to reduce network performance, such as directly parallelizing some nodes, increasing packet transmission time, and reducing PTR. The interference source usually attacks a network in the form of sending invalid wireless signals or data packets, causing the channel of network communication to be occupied or the received data packets to be damaged. Interference sources can be divided into basic interference and advanced interference. Well, basic interference can be further divided into active interference and passive interference. And advanced interference can be further divided into function-specific interference and intelligent mixed interference, as shown in Figure 3. Because of its wireless environment and its own characteristics, the mobile ad hoc network has weak resistance to interference. Therefore, many anti-interference technologies and schemes have been studied in the academic circles to improve the communication reliability of the mobile ad hoc network. For the multi-channel transmission platform of the Internet of Things, due to integrity of the sensor, the microcontroller chip, and the self-organized network structure, the data of the platform can be in and out. Among them, the microcontroller chip will use various algorithms to compare the collected data with the received data, and then realize data processing and fusion. Based on the anti-interference problem of Internet of Things communication data, the point-to-point model should be used for transmission platform. 2.2. Design of anti-jamming algorithm for ad hoc network data. Machine learning algorithms establish mathematical models based on sample data or training data, or interact with the environment so they can predict or make decisions to perform tasks without explicit programming. Existing machine learning algorithms can be classified by the expected structure of the model, mainly including supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, the machine learning algorithm has a labeled training dataset, which is used to build a model representing the learning relationship between input, output, and parameters. Unlike supervised learning, unsupervised learning does not need labeled datasets. Its goal is to classify the sample sets into different groups or clusters by obtaining the similarity between input samples. Reinforcement learning algorithms learn through the interaction between agents and the environment, that is, online learning. Finally, since some algorithms share characteristics of supervised and unsupervised learning methods, they do not fit into these three categories. These hybrid algorithms are often referred to as semi-supervised learning and aim to inherit the advantages of these main categories while maximizing their weakness. Machine learning is a research area of artificial intelligence that aims to make computers learn autonomously like humans, thereby speeding up the speed at which computers process data. The ultimate goal of machine learning is to gain knowledge from data. The machine learning model design generally consists of 4 parts: environment, learning element, knowledge base, and execution element, as shown in Figure 4. Among them, F represents the clustering processing result of the link nodes in the ad hoc network based on machine learning. H represents the cumulative times of the distance between data points and center points. This represents the change interval of the class range. K represents the average value of the link nodes in the ad hoc network. G represents the average value of the clustering weight. S represents the iteration constant of the link data in the ad hoc network, represents the p-term coefficient of the node processing constant, and D represents the node parameters of the clustering processing. The principle of link node clustering in an ad hoc network based on machine learning is shown in Figure 5. In order to improve the success rate of data transmission, the basic idea of this strategy is to replace the disturbed channel with the corresponding replacement channel. Before enabling this strategy, the node will switch to the channel indicated by the frequency hopping pattern every time slot to send and receive data. After this policy is enabled, when the frequency hopping pattern indicates the need to switch to the disturbed channel V, the internal nodes and edge nodes will switch to alternative channel V, while the connecting nodes and normal nodes will still switch to the channel V. However, only channel replacement will prevent the adjoining node from receiving packets from certain types of neighbors. The cumulative distribution function of the first order due distribution is expressed as f1, and the defining formula of this function is as follows. According to the random matrix characteristics of machine learning, we can fully understand the channel characteristics of the current communication, and this covariance matrix can verify the parameter attributes of the channel received data. The node can select channels by referring to the historical channel selection and the observation of its real state. Some scholars have shown that the optimal channel decision under multi-channel is based on the statistical data of all historical decisions and observations. The reasonable application of computer and network management can increase the transmission speed of engineering information, improve the work efficiency of intelligent engineering management and construction management personnel, improve the work efficiency of various departments of the project, and enhance the communication, and coordination among various personnel of the project. The long-distance wireless ad hoc network preferentially selects nodes with further distances as data packets, which can greatly increase the number of hops in the network transmission process, thereby reducing the delay of packet distribution, reducing redundant information in the network, and effectively improving data distribution control efficiency. By calculating the transmission distance of data packet, the design strength of the receiving node and the location information transmitted by the node can be obtained. To this end, the forwarding delayed protocol is set using the distance, so that the distribution delay of the receiving node is inversely proportional to the distance of the sending node. 2.3. Realization of anti-interference of ad hoc network data. Due to the data transmission of the ad hoc network, the following two situations will occur: the existence of the main user data and the existence of noise data. The former indicates that the channel is occupied and the latter is in the idle state. If Sk is the directional received data energy in the ad hoc network, 1 is the energy information of the data, Nk is the energy information of white Gaussian noise, the channel occupancy is set to H1 and the idle state is H0. The data receiving expression is as follows. Assuming that there are these directional channels and receiving end of the ad hoc network, the data thus collected at the receiving end at time k is described by the following expression. In the formula, the direction matrix of k equals to 1, 2, to m, and m directional channels to collect user data is denoted as this. The energy of main user data at a certain moment in the collected data is Sk. The energy noise data is Nk. Because of the communication data is more or less disturbed by noise. Based on the premise that this is established, the false alarm probability is used to distinguish 0 of the communication data types, and the description formula is as follows. Based on the characteristic analysis results of mean value m, the expression of false alarm probability p is established as follows. In the formula, the probability integral function is this, and the delay mainly occurs in the information collection process between the master and the slave clock. The slave clock sends a delay information request packet to the master clock. Unlike the synchronous data packet with a period of 2m, the information data packets sent are sent only when the delay request data packets occur, and the specific process is shown in Figure 6. The adaptive connection of the ad hoc network equipment integrates and processes the relevant operation status data according to the development requirements of machine learning theory. On the premise of meeting the automatic maintenance requirements, this data are arranged according to the current network status requirements of the ad hoc network equipment, so as to improve the detection efficiency of the operation data. In the self-adaptive connection method of the ad hoc network equipment, the direct access method, the network access method, and the private line access method are 3 common communication methods. Among them, the direct access of the ad hoc network equipment can fully connect each communication node and strictly limited the maintenance access mode of the running status data. The private line access of the ad hoc network equipment needs to occupy 1 or more data transmission channels and change the original state of this data. The machine learning theory is applied to break up the state data of the equipment in the ad hoc network, and this scattered data are combined into a new state maintenance ring of the equipment in the ad hoc network in the way of connecting the first and last in order. See Figure 7 for the detailed adaptive connection principle of MANET data. The specific implementation process of the algorithm is as follows. Assuming that there are k convolution cores and n kinds of output layers, then the weight parameter, this, of the output layer is a A times B matrix, which can be expressed as this. and the feature of their pooled sample X is a k-dimension vector, that is, this. The probability that sample X is divided into the Y category is this. In the formula, QH represents the H-bias term of the fully connected layer, and the loss function can be obtained by maximizing the likelihood probability. In the formula, R is the training dataset, and GY is the real data type of the Y sample. In order to prevent overfitting, it is necessary to simplify the ad hoc network structure according to a certain probability to ensure that the weight does not work. After feature compression, the internal state and behavior control of the data can operate freely on the basis of stable database storage space. 3. Analysis of experimental results. In order to verify the practical application performance of the data interference method based on machine learning algorithm, the following experiments are designed. The simulation experimental environment is Intel Pentium i5-252OM processor. The writing memory is 6 GB. The operation is Windows XP and MATLAB 2013 software is used as the experimental platform. The experiment adopts the multi-channel transmission parameters of the ad hoc network as shown in Table 3. The dataset used in the experiment is 1000 MB. In order to avoid two single experimental results, the method in this paper is compared with the traditional anti-interference avoidance method based on adaptive link and intersymbol interference suppression for sensor data in ad hoc networks. Firstly, verify the distribution of data by different methods, and the results are shown in Figure 9. According to the results of Figure 9, the method in this paper has a better effect on the distribution of data in ad hoc networks, and the distribution process is more stable. However, the distribution process of network methods is not stable enough. The distribution data volume fluctuates greatly. On this basis, the application performance of this method is verified. LRT channel is used to conduct the test, and the anti-interference process stimulation diagram of this method is obtained. The results are shown in Figure 10. In Figure 10, the upper graph is the successful packet sending rate curve of each cycle of the method in this paper. The lower graph is the cumulative reward curve, and the abscissa is the training time step. Figure 10 illustrates the effectiveness and practicability of our method in the multi-channel state. On this basis, keep the interference frequency of the receiver and the transmitter unchanged, and the network data of the transmitter will change with the change of the interference frequency. In this process, the network data of the transmitter is recorded as the maximum value under three different coupling coefficients: 0.004, 0.005, 0.018. After analyzing and applying the method in this paper, the relationship between the ad hoc network data and the interference frequency change. The results are shown in Figure 11. It can be seen from Figure 11 that the interference frequency is uniformly distributed around 202 kHz and is relatively small due to the change of interference data. According to the above changes in network data of the transmitting end, the operating interference frequency of the transmitting end is adjusted according to the minimum value to ensure that the transmitting end and the receiving end are in a matching state, so that the experimental results are more accurate. Conclusion: due to the increasing support policies of ad hoc networks, more and more multi-channel network environment fields are favored, and the interference generated during communication is generally artificial and non-artificial. In order to make the communication effects of ad hoc network more ideal, this paper proposes a method of communication data anti-jamming based on machine learning algorithm. This method can effectively suppress data interference and optimize data transmission performance.